Hi guys, this is going to be a video about the temperature change when two objects are in contact, right? So for example, if we had a beaker of water and we decided, okay, I have this really hot iron block and I wanted to put it into the water, well, what is the resulting temperature of the water? Okay, what is the resulting temperature of the water? Well, so there's two principles at play here. One, after all is said and done, after all of the energy transitions happen, the final temperature of the water is going to equal the final temperature of iron. Okay? So the final temperatures of both objects are going to be the same. Okay? That makes sense because temperature is a measure of average energy, and if both of them have the same average energy, then there's no real reason for them to transfer any energy. Okay? Two, well, since these objects are going to be in contact, all of the energy that one loses is going to be gained by the other. So Q lost is going to be equal to Q gained. Okay? So these are the two principles which allow us to solve this problem. Okay? So let's figure out some constants here, right? Let's say we had 100 grams of water. This was 10 grams of iron. This water initially starts at 10 degrees Celsius, and this iron initially starts at 100 degrees Celsius. Okay? The constants for this, right, Cp of water, that's 4.184 joules per gram degree Celsius. And the Cp for iron is a tenth of that. So that's 0.40 joules per gram degree Celsius. Okay. And let me just confirm that. Cp of iron, 0.45 degrees Celsius. So a little higher. My fault. All right. So, using both of these facts, we can solve the final temperature of this state when you put the iron block into the water. So we're going to use fact 2. Q lost is equal to Q gained. Okay? All of the heat that is lost from one object is going to be gained by the other object. All right? In this case, because the iron is at a higher temperature, iron is the one that's going to be losing the heat. So iron is going to lose the heat. Water is going to gain that heat. Okay? Because iron is going to be losing that heat, we're going to put a negative sign here to indicate that iron has lost its heat. And if you remember back from the specific heat equation, well, the change in temperature is from heat is directly proportional to mass, what the object is, and its change in temperature. Okay, so this is going to be the mass of iron, the Cp of iron, and the change in temperature of iron. Okay, that's going to be equal to the Q gained, right? So the mass of water, the Cp of water, and the change in temperature of water. Okay. We can start plugging in constants. So we have negative, the mass of iron is 10.0 grams, the Cp of iron, 0.450 joules per gram degree C, times, we'll just leave change in temperature. That's going to equal 100 grams times 4.184 joules per gram degree Celsius times the change in temperature. I'll put it here, of water. Okay. Combining constants, so I'm going to multiply these two out. That's going to be 4.50 joules per degree Celsius, remember grams cancel, times the change in temperature of iron, and that's going to be equal to 418.4 joules per degree Celsius times the change in temperature of water. Okay, I'm going to do one more combining step, right? I'm going to move this change in temperature here, right, of iron. I'm going to move this constant over to the other side. So I'm going to divide both sides by 4.50. So I get that the change in temperature of iron is equal to, and if we do the math, 418.4 divided by 4.5, we get 92.97 times the change in temperature of water. Take a moment to consider that, right? The change in temperature of iron is 92.97 times the change in temperature of water. That should make sense because 1, there's a lot less iron than there is water. 2, the CP for iron is a lot less. So, combining those two facts, it means that iron is going to be changing temperature very rapidly, whereas water, there's a lot of it and it doesn't really change temperature. So, it's going to be a lot less. Okay? So, we have a useful relationship here. The change in temperature of iron is 92.97 times the change in temperature of water. So the change in temperature of iron is 92.97 times the change of temperature of water. Okay, so the initial temperature of the water was 10 degrees Celsius, and the initial temperature of the iron was 100 degrees Celsius. So we're going to start plugging those values in. Change in temperature is equal to the final temperature minus the initial temperature for that substance. In this case, because both the final temperatures are going to be equal at the end, right? Remember relationship 1, I'm just going to leave it as TF, and then TI is going to be for iron. That's going to be equal to 92.97 times TF minus TI for water. Okay? So let's solve for TF. I'm going to distribute the 92.97. Okay, so TF minus TI for iron, well, that's 92.97 times TF minus 92.97 times TI for water. Okay. Or, so I'm going to move the TF over to this side of the equation. And I'm going to move, so negative TI FE, that's going to be 91.97 times the final temperature. And I'm going to move the TI of H2O, 92.97 times that, over to the other side. So that becomes TI of H2O, 92.97 times the TI for H2O. Okay. Finally, I'm going to divide both sides by 91.97, so TF is going to be equal to 92.97 times the initial temperature of water divided by 91 minus the initial temperature of iron, all divided by 91.97. Okay, plugging in values, that becomes 92.97 times 10 degrees Celsius minus 100 degrees Celsius, all divided by 91.97. We can do all of the math, and we will get, well, 92.97 times 10, well, that's 929.7, minus 100, that's 829.7, divided by 91.97, well, that's going to be 9.0 degrees Celsius. That does not make sense. I must have done my math wrong somewhere. That does not make sense. Because the final temperature is lower than the initial temperature for water, but we know water is absorbing energy, right? So I did my math wrong. We gotta check. So our change in temperature is that. We can split it up into TF minus TI. We split up the 92.97 to both the TF and the TI. I moved this over here, so that should be plus. I moved that over there, so that's minus. Okay. If I divide everything then by 91.97, okay. All right. What did I do? Let's go back. Ah, this is what I did. See this negative sign? Oops. That should be there. See how easy it is to mess up? See how easy it is to mess up? That negative sign should be there. So the change in temperature should be actually negative, right? So let's fix that up. Negative, negative. That becomes negative. That becomes positive, right? So instead of 91.7, that's 93.7 negative there. In fact, right, we're going to move that to this side, so that becomes positive. We're going to move, yeah, so just like that. 93.7 plus TI, that moves over there. Okay. So 93.97 plus. All right, let's do that math again. 93.97 times 10 plus 100 divided by 91.97 is going to be equal to 11.30 degrees Celsius. Okay, do not forget your negative. Okay, do not forget your negative. All right. Other than that, thank you. Be careful.